Today's lesson comes from Chapter 8, Section 4 of our textbook. It involves solving radical equations. The goals for today are to find the solutions to a radical equation, then to check and recognize extraneous solutions. We're going to put our answers again in set notation and make sure that we include extraneous solutions in parentheses and actual solutions in our brackets. The steps to solve a radical equation are here in the notes. It says first thing we want to do is to get one of the radicals isolated on one side of the equation. If there are more than one square root or cube root or other radical, then we just pick one. Step 2, we're going to raise both sides to the inverse power. So if we have a square root, we're going to square both sides. If we're getting rid of a cube root, we're going to cube both sides. Step 3 is to repeat steps 1 and 2 if necessary. It will be necessary if there is more than one radical in the equation. Step 4, solve what's left. Sometimes we'll get a result that's a quadratic equation, sometimes we'll get a linear equation, sometimes we'll get cubic or quartic equations. So this will remind us of some of the things we learned in first semester about how to solve an equation. And last but not least, we take our solutions, check them into the original equation, and see whether or not they are extraneous. They can be extraneous in several situations. If we have a negative number under an even root, that would be extraneous. Or if the number that we have just simply makes the original equation not true. Number 1, as we see in step 1, we need to get the radical by itself. To do that, we're going to subtract 3 from both sides. Minus 3 is equal to the square root of 24 minus 4x. Now to get rid of the radical, we have to raise both sides to the reciprocal power. The reciprocal of the 1/2 root is to square both sides. Now remember, we cannot distribute a square over a subtraction, so this will not give us x squared minus 9 on the left. Rather, we get x minus 3 times x minus 3. And on the right side, since squares and square roots are inverses, we just get 24 minus 4x. So on the right, we get x squared minus 6x plus 9. And that will equal 24 minus 4x. Since this equation is quadratic, we want to get it equal to 0. So x squared, if we add 4x to both sides, we'll get negative 2x. If we subtract 24 from both sides, 9 minus 24 gives negative 15. 0. So now we can solve it by factoring. X minus 5 times x plus 3 gives 0. So x is either equal to 5 or x is equal to negative 3. So now what we want to do is make sure that those solutions would work into the equation. So if we try 5, we get 5 equals 3 plus the square root of 24 minus 4 times 5. So we would get that 5 equals 3 plus the square root of 24 minus 20, which is 4. So 5 equals 3 plus 2. So that one works out. That tells us that for our solution set, 5 should go in our brackets. So now if we try to check the negative 3, we get that negative 3 is equal to 3 plus the square root of 24 minus 4 times negative 3. Well, if we're being truly observant, we can stop right there, because since this side of the equation is negative, and this number is positive, and since we're taking a square root, this number is positive, there is no way that I can add two positive numbers and get a negative value. Therefore, negative 3 is an extraneous solution and belongs in our parentheses. Okay, that completes problem 1. Problem 2 is a little bit different. This time we have the x on the other side of the equation. So we're going to start by subtracting x in order to get the square root by itself. You'll find that many of these examples are very similar, but end up being just a little bit different. So now we get rid of the square root by squaring both sides. So again, notice we have a parentheses around the 3 minus x. On the left, we get 24 minus 4x. On the right, we're going to get 9 minus 6x, and then plus x squared. Okay, so again, it's quadratic, so we want to get it all equal to 0. Since the square is positive on the right side, I'm going to go ahead and leave it there. Now if we add 4x to both sides, we get negative 2x, and if we subtract 24 from both sides, again we'll get negative 15. So this should look very familiar. We just solved this equation. This time we'll have minus 5 and x plus 3. So the possible answers are 5 and negative 3. So now again we need to check those two values and see whether or not they'll work in the actual 5. Minus 4 times 5, and that's supposed to equal 3. Well, again, every square root is going to be positive. So if I have a 5, is there any positive number I can add to it and get 3? Well, that's not possible. So that tells us that 5 this time is extraneous. So if we try negative 3, we get negative 3 plus the square root of 24 minus 4 times negative 3, and that equals 3. So this gives negative 3. This value in here is 36, and the square root of 36 is, of course, 6. So we get 3 equals 3, making 3 the actual solution this time. So very similar problems, but notice that what was a real solution in number 1 is now extraneous, and what was extraneous in number 1 is now the actual solution. I lost my negative there, so negative 3 should work. Alright, number 3. We're going on to a slightly harder problem. This time we have two radicals, so we have a choice. We can either get the first one by itself or the second one. I'm going to choose to get the first one. It should not matter, but sometimes can lead to a little bit easier process depending upon which radical we isolate. So this gives us the square root of 4x plus 1 equals 5. So again, since it's a square root, we're going to square both sides. Now, how do you do that? On the left, we still get 4x plus 1. On the right, we get 5 minus the square root of 3x minus 2, and times 5 minus the square root of 3x minus 2. So now we're going to have to remember a little bit how to multiply radicals. On the right side, we get a little bit complicated here. 5 times 5 gives 25. If we multiply 5 times the negative of the square root, remember that what's outside stays outside, what's inside stays inside. Then we get another negative square root of 3x minus 2 times the 5, so we get negative 5, 3x minus 2 under the square root. And then when we take a negative times a negative, we get a positive, and the square root of 3x minus 2 times the square root of 3x minus 2 is just 3x minus 2, because you're squaring the part that's under the square root. So to simplify this, we have some 25 stays the same. Well, actually, let me take that back. We can combine the 25 and the negative 2 at the end and get 23. Negative 5 and negative 5 gives us negative 10 square roots of 3x minus 2. And then we have plus 3x. So the next step would be to isolate the radical again. So what we want to do is get the square root of 3x minus 2 alone on the right side of the equation. So we'll subtract 3x and get x on the left. If we subtract 23 from both sides, we get x minus 22. So having a calculator handy is going to be really valuable here in just a second. So then we get negative 10 times the square root of 3x minus 2. And sometimes it'll be easier to get rid of the radical at this point, even though it's not all the way by itself. If we were to divide by the negative 10 on both sides, that'd be okay, but it's going to create fractions, and then we're going to have to square with the fraction. So let's just go ahead and square now, because we can still eliminate that radical. But because this is a product, and we're squaring a product, we need to remember to distribute the square to both parts. So on the left, we're going to get 44x, and then 22 squared is 484, so we get plus 484. Negative 10 squared gives 100, and then we have a parentheses because we're multiplying that by a binomial of 3x minus 2. So now, I dropped my square there. So we can distribute on the right hand side. We get x squared minus 44 is going to equal 300x minus 200. So now to work on this one, we want to, again, get from both sides. We get negative 684, and that equals 0. what can multiply to be 684 and multiply to be add to be negative 344? Well, if we don't look too hard, it's actually pretty easy. Half of 684 is 342, so we can use x. So that gives us answer of 342. So if we're going to plug these back in, I'm going to do this a little bit quicker with the 2. I'm going to check the 2 first because it's a little bit easier. In the first square root, we get 8 plus 1, so we get the square root of 9. In the second square root, we're going to get 6 minus 2, so that's the square root of 4, and that's supposed to equal 5. Well, 3 plus 2 does simplify to be 5. So 2. Now if we try 342, again, it might be nice to have a calculator handy. So we're going to take 4 times 342. 369. That's 37. Alright, then we're supposed to be able to get rid of that. Made my square root a little bit too big here. Add to that the square root of 3 times, and then that's all supposed to equal 5. Well, again, I already know that my first square root is 37. I'm going to add some positive value to it, and there's just no way that that can equal 5. So that tells us that 342 is extraneous. What we just did. So if we don't finish it, and get the 4x plus 1 by itself, let's see, we'll get 5 plus this time the square root of 3x minus 2. On the right side we get 25. It's going to again, and then plus 3x minus 2. So again, we want to try to isolate. We get x. 25 minus 2. So we want to subtract 23 from both sides. And that gives us the 10 square root of 3x minus 2. So we get x squared minus 44x, and again 22 squared was 484 times 3x minus 2. So again, quadratic equation, so we're going to try and get 44x. We add 4, and I'd bet you it's going to factor x minus 342 times x minus 2, just like the last one. So x is 342 or 2. And if we try those again this time, if we try the 2 first, we're going to get 8 plus 1, which gives us the square root of 9, minus 6 minus 2, which gives us the square root of 4, and that's supposed to equal 5. So we get 3 minus 2 equals 5, which is not true. So that tells us that 2 is going to be extraneous. Now if we try our value of 342, again, from the last problem, we saw that the first radical is going to give us the square root of 1,369, which is 37. This time we're subtracting. That gives us 1,024. And the square root of 1,024 is 32. So this time we get 5 equals 5. Therefore, 37 is an actual solution. That concludes our examples today. The homework tonight is page 428, the quicks, and then exercises 1 through 21, the odd. Next time we meet, we will talk about how to solve some equations with fractions in them. Just note, if we have a cube root instead of a square root, that simply means we're going to cube both sides instead of square both sides. Good luck.